Hello and good evening to all of you. I hope you are all keeping well and safe. Thank you for joining us for this interactive webinar. We will have just a little bit of a brief on the interactive part of the webinar. We will be having two Q&A sessions, one during the middle of the session and one at the end. And if you would like to ask your questions directly to Dr. Subramanian, please send in your questions in the Q&A box and click on the raise hand option, and I will unmute you so you can ask your questions directly. Thank you. And we have with us, thank you, Dr. Subramanian, who will be joining us this evening. He is an alumni of IIT Madras and obtained his PhD from Cornell University in the area of electrical engineering and specialized in micro-electromechanical systems. He previously worked at GE's Global Research Center in New York and has over 50 patent applications in his field. He's currently the executive director at the R&D at Powergear R&D, based at MEPS in Chennai. Thank you, Dr. Subramanian, for joining us this evening. We're really excited to have you and to hear your thoughts this evening.
Yeah, so thank you, Chandni. Thank you for having me over.
Thanks. So, I wanted to ask you, you've told me this during our discussions, that the Powergear R&D division is a division that you set up after you came to India back from America. So what was your motivation to set this up? And can you also give us a bit of an introduction into Contract R&D?
Sure. Let me lead you through a little bit of my own history in order to answer this. So I got my PhD at Cornell in the US, and then I joined GE General Electric as a scientist. And what kind of hit me at that time was the vast difference between the research that goes on in industry and what is perceived as research, which is most often academic research. Right? And of course, all scientists came from an academic background. So we all start from that as the foundation. But what happens in industry was something completely different. Of course, the science is the science. But on many counts, what hit me was, for example, the first point was the fact that we don't work on our favorite problem and then wait for someone to pick up the results and start selling it. So we always in industry work in reverse, right? In other words, you start from the market, you find out what the market needs, not now, but in a few years from now. And then with that vision, you kind of work back to figure out what research needs to be done today to fulfill that vision. So that was one staggering difference. In other words, you have the application for the research already available. So if you're successful, then you have a path to market. So that was one. Secondly, the truly multidisciplinary nature of research in practice. Because today, gone are the days where people are pure mechanical engineers or pure electrical engineers, etc. I think you have to be jack of all arts and master of at least one. So that's the name of the game. And research is like that. And they have the saying that innovation happens at the intersection of disciplines. You need multiple skills to come together to even create the simplest of inventions today. So that is another thing that truly struck me. And thirdly, the importance of something like intellectual property, where it is who owns the intellectual property, which is the output of the research, is a very, very critical fact. And finally, the practical nature of the research, right? So in other words, what people think of research is often experimental work, lab scale prototypes, etc. But what is also required in addition to that is the understanding of cost, the understanding of life, reliability, understanding of supply chain, which is not commonly included in the topic of R&D, but it very much is in reality. Because unless you keep all that in mind upfront during the concept phase and during the experimental phase, then you're probably doomed later on, right? Yeah. Because unless you think of all this early on, there is a good chance that things may fail later. So all of this wrapped into itself is what we call industrial R&D. And the idea of contract research, back to your original question, is the sum total of all these offerings. So in other words, an offering where you start from the market and you work backwards to find out what research needs to be done or what new technology needs to be invented to fit a certain industry's timeline in terms of what new technology they are launching in the coming years. Secondly, the multidisciplinary team, which constitutes contract research. And thirdly, the product-oriented thinking. And finally, you need friendly intellectual property terms. Right? So what we do is we actually offer contract research where the client owns all the IP. So we have a very clean situation there, right? So in other words, we become truly an extension of someone else's research facility. If they have a research facility in-house, we become an extension of their team because whatever we invent also completely belongs to them. If they don't have a research facility in-house and they don't want to create a multidisciplinary team of scientists, a multidisciplinary set of labs, then we are their entire R&D lab, right? So that's what contract research really means. So, so to summarize, concept to manufacturing in a multidisciplinary way, IP-friendly way, timeline-bound, and which also means that you have to very closely engage with the customer through regular reviews and stuff, because research is a little nebulous. You have to allow yourself and your customer to steer the research program dynamically, because as you invent more, people will also, I mean, more and more options open up. So your customer himself or herself would also steer the research potentially in different directions, in better directions, right? So to maybe put it a little lightly, I think the stereotype of a scientist is someone with glasses and French beard sitting in a corner and doing what they want. So, but in industry, it's very, very different. So it's extremely practical. It's also fundamental, and fundamental, would say, is not the opposite of practical. You need a lot of fundamental science to get to a practical vision at the end of the day. So that's what we do in a nutshell.
Okay, wow, it's quite a good summary. Thank you. So is this like, it's quite a new concept in India though, isn't it, contract R&D? I don't think there's any other center that's actually has got a contract R&D division.
I don't think so. We have tried to look for people like us, just like human beings are looking for aliens, and we haven't found any. So we hope there are, because truly to achieve the vision of serving the R&D market, which we believe is huge, we believe that we need to see a lot more people like us in the business, in the true spirit of research, right? So maybe I can give you a very simple example just to take you back to what, to the excitement of research. Right. So when I was working as a scientist in the US, we were trying to miniaturize electrical equipment. We were trying to ultra miniaturize electrical equipment. And in other words, we reduced the size by about 1 million times. Okay.
Wow. Okay.
To think of power equipment, it's all huge things. And reducing the size of that is actually a big deal. And actually reducing the size comes up with other benefits as well. So we were posed with a very fundamental problem as to how do you send a lot of current through a very tiny piece of wire. Everything boiled down to that. So if you make everything smaller, then the metal that you're passing the current through becomes extremely small, right? And if you go to the shop today, if you go to any electrical shop, if you want a 5 amps wire, he'll give you a thin wire. And if you want a 15 amps wire, you get a fatter wire.
Yeah.
Right? And intuitively, that seems to make sense, because you would think that a fatter wire would pass more current because it's got more cross-section. Unfortunately, that's complete nonsense. And we realized this the hard way, and the result was in fact a good result to have, because it turns out that theoretically the size of the wire is not the limiting factor to kind of figure out how much current you can pass through a piece of wire. right? It actually is a completely different problem. It's actually a thermal problem. So what happens is if you pass a lot of current through a small piece of wire, it heats up too much. So the solution then presents itself, right? It says that if you can maintain the temperature of a wire, you can actually pass a lot of current through a very small piece of wire.
Okay.
Right? So just this fundamental understanding, right? So gives you a very, very, very exciting result. So again, just to take you back to what R&D means, right?
Yeah.
Just to make people feel the excitement. So just this little fundamental understanding that how much current you can pass through a little piece of wire has nothing to do with the amount of metal. It actually has everything to do with how you keep it cool, right? Then solution is easy to find, right? So just a little example to wake people up.
Yeah. I know. Work from home, we all need this.
Yeah. Mm-hmm.
So please tell us, what in Powergear R&D, in your contract R&D division, what type of projects do you work on, or what kind of industries do you cater to?
Okay, great question. And we are, to just state the obvious once again, we are an R&D services firm. We are not a pure engineering services company. There's a lot of engineering services company out there. So the way we distinguish ourselves is we take projects that have a research component or an innovative component. So the project is not just a design or a simulation. I'm not saying those things are easy, but those things are one portion of R&D. So we take on projects where today a solution doesn't exist at all. Right? For example, a sensor that somebody wants that hasn't been invented yet. A new kind of battery, if you will, which doesn't exist, which, I mean, people pose all kinds of interesting problems. We are, for example, working, to take the battery example, someone posed a problem saying that they want a battery that charges from 0 to 100% in 10 seconds. Which is something that just doesn't exist. So the best lithium battery today can do about 80% charge in about 30 minutes, practically speaking. There's a few better examples in the research phase today. So someone posed a problem saying that can you make almost what is essentially an instant charge, right? Since instant is not practical, they told us 10 seconds, which is almost right. So because, yeah, and if you think about it, it's a real need of the hour, because as electric vehicles become more popular, people don't have the patience to hang around for a half an hour, 1 hour, 2 hours to charge their vehicle. Today, the time it takes to fill petrol or diesel is about 5 minutes or 10 minutes max, right? If you have to wait. So even that feels a little too long, and people are impatient to wait that long. Something that can be done in seconds is probably the solution, if it's possible. So again, this is R&D because it sounds impossible. It sounds crazy to start, right? So what we would do is we would put a team of scientists, and the battery initially sounds like chemistry. But when you pose the problem saying you need an energy storage device which charges in 10 seconds, may not be chemical at all. Because chemistry involves the movement of ions from one place to another. Ions are bulky things and they move slowly, right? So you will have to think very differently. So we would assemble a team of scientists spanning, of course, chemistry, but also electrical engineering, thermal sciences, because how much heat you kind of generate in this process is an important thing. And any discipline that we can lay our hands on, right? And then we brainstorm as a team to come up with equally crazy ideas for the crazy problem. And then we maybe come up with 2 or 3 ideas, which maybe can work. And then we go on to the next phase, which is experimentation. We figure out which of these concepts have better promise through little experiments. We don't make the whole battery, but we make small portions of it to prove or disprove that any of these concepts can work. And then the winning concept comes out, which is converted into a complete detailed design and a prototype and so on. So that's how we work. And we are organized by technologies, right? We're not organized by industry segments. So we have expertise in electronics, in materials, in chemicals, in power, in mechanical, in thermal sciences, and so on. So when we serve a particular industry, in other words, when we, in fact, we work with automobile, we work with aerospace, we work with chemical process industry, we work with iron and steel, consumer, medical instrumentation, energy industry. The reason this list sounds big is because we are organized by technology, and any industry, any domain that comes to us, we mix and match and create a team of scientists for that domain. Yeah. So we are quite agnostic to the actual application domain, and we are organized really by the technical expertise.
Yeah. So, you know, like for instance, what you were saying, even in the battery developing a battery storage device, I mean, this must take some time. So usually what kind of like budgets and timelines do you have for the R&D projects? Do they all vary or?
Okay, so that's also a very good question. So R&D is not cheap. So I'm glad you asked that question. And that's one of the issues we face. I mean, to be very honest, certain customers start off thinking that R&D can be done overnight. Not literally, but they think R&D can be done in a very short time at a very low budget. It doesn't happen that way because you need strong expertise in terms of manpower. You need the facility. You need to try out many different parallel concepts. And that's the only way to reduce the risk. Because if you try out, let's say you have one idea and you just try that out, you probably have a very high chance of failure. So one way we mitigate risk is we have 2 or 3 parallel paths, and something will work, or some combination of these parallel paths will end up working, right? So I would say that our smallest project is roughly about 8 months in size, give or take, right? Because below that, it's probably not R&D. Below that, it's probably basic engineering. Yeah. And if it's R&D, if there's an innovation component, if we're really inventing something new, then and even 8 months is a very short time, but that's our bare minimum in terms of size. And we have projects that go on to several years, as a matter of fact. It depends entirely on the kind of project. In terms of budgets, I think we start at about 50 or 60 lakhs per project. But then the sky is the limit in terms of how big the projects are. So that probably gives you a very ballpark kind of idea. But how we actually operate is when we start engaging with the customer, we first sign a non-disclosure, an NDA, and then we sit with them and hear their pain points. We hear their vision as to what they want in terms of technology in the coming years. And we work with them, as I said early on, to work backwards to see what R&D program is required today. And then we come up with a very professional technical proposal and eventually a commercial proposal, which has a very clear scope, timelines, deliverables, right? Who's doing what? Because often there is a complementary team at our customer side also, which is working on this. So all of that is very clearly described in a very professional way, and we stick to those timelines. And once we promise that we are going to deliver something, the rest is on us. So even if something goes wrong, we have to find an alternative way to complete the project. So in other words, we quote on a project basis.
Okay, yeah, so it's good that the customer has all the details right at the start, including the timelines as well, so they know what to expect.
Exactly, timelines and tentative concepts even. Of course, what concept will really end up working will be decided during the course of the project. And often the specifications given by the customer include commercial specifications. In other words, people may say, I want to invent a certain kind of appliance, which has to cost approximately so much when it is complete, when the project is complete.
Okay,
so we take that as a target.
Yeah.
So we take commercial targets as well.
It's important. Yeah. We have to translate into a usable, commercially viable product. So, marketing such R&D services, what are your challenges? I mean, do you think India is ready for outsourcing R&D?
Uh, Another great question. So let me just back up a little bit. We believe that everybody needs to do R&D. Okay, whatever the product is, we believe there is scope for innovation. I don't think there is any field in the world which is saturated in the sense that nothing more can be done, right? A very simple example maybe is in the US or in many countries, even a little bit in India, people use dryers along with washing machines, right? Of course, in Chennai, we have a lot of sun, which is true of most of India, so we don't need to use a dryer. The example is that a lot of people in the US were making dryers. And this became a commodity and the competition was pretty huge. And hence the price was kind of the optimum price, which without much of a margin for any of these players, right? But one of these players came up with an idea of putting a humidity sensor inside a dryer. Okay, so something that measures, so dryer is just a drum which is tumbling the clothes, and there's hot air getting blown while the clothes are tumbling. So the clothes get completely dry in a certain time. But the problem is a dryer consumes a lot of power, right? And then what the humidity sensor did was it measured the humidity inside that drum as the clothes were tumbling. And when the humidity reached a certain threshold, the dryer said, okay, now I believe your clothes are dry. Right, so it can give you a buzzer or an LED or something, some indication. Right, so what that allowed people was to stop the dryer at the right time, rather than just let it run without knowing when your clothes are dry.
Yeah.
Right, so that alone, I mean, the humidity sensor was probably $1 or $2 in cost, but that innovation allowed that particular player to charge a huge premium for that dryer because it really added value to the drying process.
Yeah.
Right. So that is an example of innovation in such a simple product where you just simply blowing hot air and rotating a drum, right? Which is hardly much of high technology, right? Which kind of goes back to my point, which says that in almost any product innovation is possible, right? So we try to work with our customers to explain that first, right? And honestly, it is not easy to get customers. It wasn't easy, at least. I think things are improving. It was a little bit of an uphill battle to start with when we started this initially, because to be really, really honest, the issues are so on. See, one is you need a budget, right, for research. And many companies have the budget, but it has to be an allocated budget for R&D. So unless you plan at the beginning of the financial year and say that and decide that you're allocating so many dollars or so many rupees to innovation, to a long-term vision, right? If you don't do that, then you'll have to pull the funds out of something else, which becomes a problem. So that I think is the perception problem, right? So have you planned for R&D? And hence do you have a budget allocated saying that this is only going to be spent for R&D? So that is one learning that our customers need to kind of acquire, which I think the scenario slowly in India is changing, right? Secondly, of course, you need a long-term vision, which sadly doesn't exist in many cases. A lot of people have kind of realized that unless they invent, unless they innovate, they probably will not survive in the same business for more than a few years' time, right? So many people have realized that. But what to do next? The answer is you need a vision. Where are you going to be in the next 3 years or next 5 years, right? This is where I'm going to launch in terms of technology. And then you need to work back to have a research program. So that is kind of lacking. So we are working hard with our customers to infuse that vision, right? So have a vision. And then once you have a vision, you will automatically allocate budgets, right? And so R&D is not an afterthought. Right? It has to be something that is very carefully planned, right? And secondly, a lot of Indian companies have the tendency to just wait, watch, and acquire technology rather than develop it themselves. And that's fine. I'm not saying that's entirely wrong, but I think you need a healthy mix of acquisition-based growth and your own internal organic growth. Because organic growth is what really allows you to own that technology.
Yeah.
Right? And you can truly, if you really invent your own technology, you truly understand it, you also truly can develop on top of it and make further versions of that technology. Right? So all of these together need to come together. So is India ready? Yes, yes and no. I think certain companies in India are thinking this way. But I think very soon India won't have a choice. Right? I think R&D is here to stay. Right? It's I think just like you say that change is a constant. R&D is the only thing that can give you that change.
Yeah, so it's good. Hopefully, industries are more and more industries are changing their thought processes towards R&D as well. So hopefully they'll be adopting this, like you said, not as an afterthought, but more in the planning as a requirement for their industry, where they have to invest into it. So, but with the pandemic going on right now, the biggest thought going in all our heads is, will companies stop investing? Because already they're quite shy towards R&D. But do you think they'll now stop? They'll become a bit more skeptic towards it, or will this? What is your advice to industries regarding R&D projects?
I think yes, they will, but they shouldn't. Right? So it's easy to say, but hard to implement. Yes, they will, because I think it's common sense that companies will think of paying salaries and working on their immediate needs first, right? So we can't deny them that. Always that takes precedence. But also, in fact, during this pandemic, we are trying to work with a lot of our customers, and even find new customers, in fact, and literally explain to them why you should be investing in something new during the downturn. So that when the upturn happens, and it's going to happen, right? When the upturn happens, you are the market leader, right? So always during a downturn, if you have the bandwidth, right? Or you should somehow find the bandwidth to take the risk and invest in new technology. And because investing in new technology is not an overnight process. It takes time to develop the technology. It takes time to integrate and actually offer it to your customer. And if you can do that during the downturn, then you're literally ready for the upturn. So when the upturn, the day it happens, you can literally launch it, right? So this is a big deal. For example, I'll give you a simple example. Electric vehicles are a big deal now, right? Everyone's talking about it, right? People are saying that is the future, IC engines will go away. And if you think about electric vehicles, the single biggest issue, which is the reason why it's not able to compete with conventional vehicles, is the range. If a conventional vehicle, if you fill petrol or diesel in your car, you can go maybe 700, 800 kilometers typically in one fill. Electric vehicles are nowhere near that, right? So you need to carry a huge battery weight, and your range is maybe 100, 150 kilometers, typical, right? I mean, certain very exotic vehicles can do a little more, right? Like a few high-end Teslas of the world can do a little more, but still nowhere near a petrol engine kind of vehicle. So we have kind of taken that as a case study, and we are trying to tell the electric vehicle industry one very simple fact, okay? Just like this, sending a lot of current through the little wire kind of example, here also, it may seem very intuitive to say that more battery gives you more distance.
Yeah.
But that again is complete nonsense, because if you think about it, think through the physics, it's actually not true. Right? Brute force, yes. If you put a bigger battery, you can probably, so twice the size of battery, you can probably drive twice the distance. Brute force, maybe that sounds true, right? But if you go back, again, this is a technical talk, right? So maybe if I can just mention something that everybody learned in high school, which is Newton's second law, force equals mass times acceleration, right? If you go back to that very simple fact, F equal to ma, right? It tells you that you need force only if you have acceleration, right? And a force is what does work and consumes energy from the battery. Force times distance is work, and work is energy, right? So the amount of battery that you consume is proportional not at all to the distance that you're driving, but only to how often you accelerate. Okay, which in turn kind of depends on how often you brake, because every time you brake, you need to accelerate back to your speed again. So in other words, what that means is if you're, let's say, traveling from Chennai to Bangalore, which is about 350 kilometers, theoretically, if you accelerate once in Chennai, right, over the first, let's say, 30 seconds or so, you should be able to cruise at that same speed all the way to Bangalore without any additional fuel or battery consumption whatsoever, theoretically. Right? Yes, we are ignoring some air resistance and some friction and all that, but to first order, you should actually be able to travel all the way or the entire 350 kilometers just by accelerating once. And if you maintain a uniform speed, you should not need any additional energy at all. That's what the physics tells you. Right? So why are we working on bigger and bigger batteries? We should be working on more intelligent controllers in the electric vehicle, which limit the acceleration to only in situations where acceleration is really needed. Right? All electric vehicles come with a full power electronic controller. I mean, you have to have that because you need to control your motor speed and torque. So you have a controller. So if you make that controller more intelligent and make it really understand when acceleration is needed, and that is when it will allow the motor to accelerate, that alone can extend the range of your battery significantly. You don't necessarily need a bigger battery. Right? So there are fundamental facts like this, which people are, entire industries are kind of aimlessly going ahead without understanding fundamentals. Right? So that again kind of goes back to the power of R&D. And I think a country like India, where I think putting a bigger battery is a very expensive proposition. Right? And if you do that, people are not going to buy that electric vehicle. Right? And so we need to have fundamental insights of this sort. So we are trying to get these messages across to industries, in this example, electric vehicle industry, to say that you're probably running after the wrong thing here, right? There's other ways to solve the same problem, and that is what R&D is, right? So no straight answer to how this pandemic is going to affect us, but I really believe that if people think through the pandemic carefully, they will use the downturn to invest in research topics so that they will be much more well off. And those are the people who are going to win when the upturn happens.
Yeah, that's good. I really hope people actually go ahead and invest in these projects as well. But you know, your R&D, contract R&D services, do they find a place in the government of India's Make in India initiative?
Yeah, I think it has to, because you cannot do Make in India without inventing in India first. Right? That's a very fundamental fact, which I hope the government has realized. So Make in India literally means you'll have to manufacture the part finally in India. Yes, you can acquire the technology from abroad and manufacture it in India. That's one way to do it. But I think we all know that foreign parties who do technology transfer to India, in most cases, make sure that they still keep to themselves some key pieces of the technology. So the portions that are transferred to India are not always necessarily the more interesting pieces, right? So yes,
the background idea.
Exactly. Yeah. So yes, we will be able to manufacture some bits and pieces in India, and that may qualify as Make in India for a while. But I think the ultimate goal of Make in India should actually be creating something here and eventually making it here, right? For which, again, back to R&D, R&D is going to be extremely critical. Okay, so how much this realization is there in the government, I don't know, right? But being in the field of R&D, we are still trying very hard to work with the government, and it's not been very extremely successful. I think we will see more success this year. The government has started a few programs, right? So for example, there is a program called Technology Development Fund by the DRDO, where they literally give out research projects to industry on what they call T1 terms, not L1 terms. So they don't have to look at lowest cost. They only look at T1, which is the best technology. And they provide funding for technology development within India, which is an excellent start. But in the larger scheme of things, we don't feel the government has actually realized that industrial R&D labs of this nature are playing a big part in the R&D ecosystem. This is something we have to fight. We have to explain patiently to the government and literally include the government as part of this R&D ecosystem to make this successful.
Okay, but it's good. At least they have some new funding and schemes as well. I think even for small startups based in incubators, I think they're trying to promote it with different funding schemes and to promote R&D. But again, those are on a much smaller scale.
It's a much smaller scale. So my wish list would be for government. See, government for some reason thinks that research is done in academic institutions and industry is simply a user of that research. So they seem to have this in black and white in their minds. And I hope I'm wrong, okay? I really hope I'm wrong, but this is the perception that I have obtained after many years of trying to work with the government. As I said, there are exceptions, right? But in general, most calls for proposals are based on this logic, that academic institutions is where research happens and industry is where research is consumed, if you will. Right? So in other words, all of these calls, the expectation is that a grant will be given to an academic institution and industry will supplement that grant with their own funds and all the work will happen in the academic institution. But if you ask me, majority of the research actually happens within industry. Majority. It's actually true. I mean, I've worked in industrial research labs and I've seen this with my own eyes, right? Majority of the research spending happens within industry. So if there is a way to allow intermediaries like us, right, where we bridge the gap, right? We can work on one side with academic institutions. We can enhance that research. We can make it more practical. We can steer the research from day one to be more practical, right? So that the probability of success of that research now becomes much higher, right? So maybe a three-party kind of thing is my wish list, where there is an industry consumer of R&D, there are academic and industry doers of R&D, right? So I think that three-party kind of ecosystem will truly work wonders. So the government can find a way to fund such ecosystems for research. I think that will solve a lot of issues. Today, the government is literally lamenting that a lot of research has not seen the light of day. A lot of research that they have funded has not, has made it to a lab scale demonstration, but has not made it to a product. So I think this is the solution for that.
Yeah, that's true. It's true. I think having a dedicated center for it with all three parties is really the key to promote it to a much higher scale. I think these concepts exist in other countries, in the US and in Europe as well.
Exactly, exactly. And I think all three parties have to be involved from day one, because all three parties have to together steer that research. And it has to be beaten upon the researcher's head, literally, that this is always towards a certain product. And that line of sight to the product has to be there every day from day one.
Okay.
Yeah.
Okay. Well, wow, that's quite a really interesting first session, half session. So I think at this point, we could probably take in some questions as well. And if anybody would like to ask Dr. Subramanian the questions directly, please click on the raise hand option as well. We have some questions here already in the Q&A box. So we've got one from Mr. Madhusundan, who would like to know, international customers outsourcing R&D to India may be a cost-effective model, but do you also have Indian customers? Oh, I think.
Okay, so let me answer both parts of that question. Yes, international customers outsourcing R&D to India sounds like a cost-effective option. But, and it probably is quite often, but we are not playing up that point because R&D is a premium service. And we don't want to belittle ourselves saying it is a low-cost service. In reality, yes, I think he is right. There is a cost difference. There is a difference in cost. There is also a difference in overheads. So there is a net cost difference, which helps. Indian customers, yes. In fact, right now, interestingly, majority of our customers are Indian. Maybe because we are physically in India and we are able to access Indian customers easier. But as I said some time before, there are issues with customers in India where the ability to convince them to allocate budgets for R&D, have that vision, work back from that vision, have that line of sight to product, that is a little bit of an uphill battle, to be perfectly frank, right? But then Indian customers very much are funding us.
Thanks. I've got another question from Mr. Somi. He wants to know, R&D is mainly confidential and for good reason, but do you feel this should be known to a wider audience that is currently addressing? And also, would increased tax breaks and concessions encourage larger outlays towards R&D?
Okay, so the first question, I think I can see it in the chat window
The
here.
chat box, yeah.
Yeah. Yes, R&D is extremely confidential, and it's beyond confidential. It's also IP sensitive. So confidential means that the information that's disclosed between the two parties has to be kept within those two parties, which is a starting point, which is where the NDA, the non-disclosure, comes in, which is, we signed that right at the beginning. And for us, it's the most precious document, because that's the honor kind of in the agreement. But then the even bigger piece is the intellectual property. So as you go through the R&D project, ideas come up, right? And as I originally said, we have kept our model very simple, where all the intellectual property that comes out of the project belongs entirely to the client. So which keeps the intellectual property discussion very simple. There is no discussion, right? So in that sense, intellectual property is critical. There is a lot of debate on intellectual property, right? There is a school of thought that there should not be anything called intellectual property. Everything should be known to the public, because everyone then can then use it and develop on it, yeah. Right? Which is, I think, a very, what do you say, a nice way to think about it. There's the opposite school of thought that says the fact that you're allowed to exclusively own certain intellectual property is what incentivizes you to innovate. The fact that you can make money out of this intellectual property is what incentivizes you to innovate in the first place, which also I think is right. So I think the jury is out there in terms of what is the right way to approach intellectual property. I think India as a country, we a little bit resisted intellectual property early on, but then we are now very much in favor of filing patents and all that. So I think there's truth both ways. Right? But this is an ongoing debate throughout the world. I don't think we can solve it in today's session. Second question, increased tax breaks are actually happening. So there is a process by the Department of Scientific and Industrial Research, DSIR, Government of India, where you can apply to be recognized as an R&D center. And if you're approved after their audit, you do get tax breaks as an R&D provider. So that exists. But I would actually go one step further, and again, this is a wish list kind of item. I would almost, again, this is debatable, right? I would almost request the government to ask people to pay an R&D tax, just like CSR in some sense, right? In other words, ask people to compulsorily allocate a certain percentage of turnover to research, right? Yeah. Sometimes regulation is what drives markets.
True, yes, right. Yeah, it's required.
Yeah. Again, this is a wish list, I think, because I'm in the R&D business.
No, I think it's quite a good question, a good thing to have on the wish list. We have another question from Mr. Sachdeva, who would like to know, what is your opinion should be a typical R&D budget as a percentage of revenue, in-house or outsourced, for a good progressive company?
Okay, it really varies depending on the type of business. And there are companies, I don't know, that have upwards of 10 or 20% in terms of R&D budget, because their whole business is innovation, right? And there are companies like IBM who I think correct me if I'm wrong, but probably has the largest number of patents in the world, right? So they have a slightly different kind of business where they seem to be filing a lot of patents and the numbers also matter, right? But then there are certain other kinds of business which do not invest a lot in R&D, and they may not need to also, right? Because there are certain businesses that are very routine in nature, which are extremely, like, for example, auto component manufacturing. I'm not saying innovation shouldn't happen there, but I'm just saying that, for example, we have met a recent auto component manufacturer who makes a certain component where the standard is everything. In fact, if you read the standard, you will pretty much know exactly how to make this. So the standard is so detailed. So there's not much scope for looking this way or that way, right, in terms of innovation. So if you innovate, it has to be radical. It has to be a completely new way of rethinking that product, right? So I know I'm not giving a straight answer to this question, but I think the real answer is that it completely varies depending on the type of industry, but everybody should have an R&D budget, which itself is not happening.
Yeah. So we'll take one last question in this section. This is from Lucas, who wants to know, is AI and generative design reducing R&D timescales?
I think AI itself is an R&D topic today, right? I don't think it's at the level where it is replacing the innovation process today. There are certain tools which help the scientist to invent. Though you would think that innovation is a process that suddenly comes to you like enlightenment, where you sit and stare at the ceiling in a room and suddenly you have a glimpse of what that new idea is, right? But often it's not like that. I mean, often it's teamwork. You think a little bit, you kind of then sit and discuss as a team, and then sparks fly, and then you have ideas that come out, right? So I don't think AI is helping R&D, but then the person who asked the question is free to look up tools like TRIZ. There's a tool called TRIZ, T-R-I-Z. It's actually a Russian acronym. So if you translate it to English, it stands for Theory of Inventive Problem Solving. So what they have done is a very interesting thing, is they have gone back to the beginning of patenting, which is a couple of centuries ago, and they have documented every known patent, and they have classified these patents in terms of the problems that they are solving, right? And they have made a search tool which allows you to relate modern problems to problems that were already solved in the past. So in other words, if the solution has been already invented to a similar problem in the past, you don't have to reinvent the wheel anymore.
Yeah.
Right? So they have kind of abstracted these older patents and they have kind of made it like a keyword search where you can look up similar problems that you face today that you're trying to solve through R&D. And it's possible that someone else has solved something similar for maybe a different application, but that solution could apply to you, right? So there are tools like that, which you could kind of partially call AI, I think, because it replaces the thinking process to some extent, right? So it's, again, the acronym is TRIZ, Theory of Inventive Problem Solving, and it's a very useful tool to scientists, right? To give us very simple example, if you take, when you do research, you end up in conflicts. So you have to solve one problem at the expense, you'll have to kind of solve one feature at the expense of another feature.
Yeah.
A very, very simple example would be, if you make something stronger, you usually make it heavier.
Yeah.
So a classic problem that's posed to you, maybe make this item stronger for me, but also make it lighter, right? So if you go use that TRIZ tool, and if you look at past examples where people have found a similar conflict in their design, where it needs to be stronger, but not heavier, right? And then you will, the tool will present how else people have solved this problem. For example, drill holes into it, right? So drill holes in strategic places so that it's stronger and yet lighter, right? So that'll create ideas in your mind as to how more easily you can solve the present day problem.
So, moving on, like, what do you think will be future trends in R&D, and does it accelerate to Industry 4.0?
Okay, so it's a broad question, right? So the thoughts I have on that are, so when you think of it in the Industry 4.0 perspective, right? There is a school of thought that most hardware has been invented, because Industry 4.0 is all about how you use the existing hardware, but gather the data that it's generating, and then make more intelligent decisions based on that data, right? Yeah. So there is a school of thought associated with this, that a lot of the hardware that needs to be invented has been invented. So you have all the machines, you have sensors mounted on those machines, which are measuring and therefore generating data. And then the next question is what to do with that data, rather than invent more sensors and more machines, right? So I think that that school of thought is partially correct, though I wouldn't agree that all machines and sensors have been invented as yet, because a lot of our R&D programs are in inventing new machines and new sensors, actually, right? So even if you take the most basic sensor since the dawn of time, which has been a temperature sensor, which was almost the first sensor that was invented. A thermometer, which you put in your mouth, is a temperature sensor, right? So you can make the case that a temperature sensor has already been invented, but we are still getting requests to invent newer kinds of temperature sensors, right? For example, a very recent request we got was to measure temperature in a very tiny space, and that tiny space is running at about 1200 degrees Celsius. So you need a sensor. So it's basically a thermometer, but it has to be built out of materials that survive at 1200 degrees Celsius, not just for the sensor, but you need electronics that does the readout, which reads the sensor and gives you the data also at 1200 degrees Celsius. All of them in a very tiny compact space, which is extremely challenging, right? So as you can imagine, even in a topic like temperature sensors that you may think is done to death, there is a lot of scope for innovation, right? So, but having said that, back to Industry 4.0, Industry 4.0 is asking the questions on what we can do with the data that's coming out of these sensors, right? So I think there's a lot of R&D happening there, right? Because this is a classic case of interdisciplinary knowledge, where you need to understand the electronics, the way the sensor works. Also, you need to have the domain knowledge of that machine that you're trying to kind of make more intelligent, right? So, for example, I mean, if you take a very relatable consumer level example, a lot of people own cars today, right? And you only remember that one day that when your car did not start.
Yeah.
Right. Every other day, you kind of take it for granted that your car is a workhorse. If you turn the key, it starts, right? But if you could make that car more intelligent, right? So why didn't it start? Because, okay, probably there was a problem with the battery, which is the most probable cause, right? So if you could add intelligence, keep gathering data from that battery, and look at kind of the life curve of that battery, right? Where the battery is deteriorating slowly with time. And then maybe a week ahead, predict that your car is not going to start next week, right? Then it's a big deal. So that's kind of what Industry 4.0 is, right? I mean, I know this is a consumer level example. It's not an industry example, but that's where we are heading. Because I think getting data from a battery, it's just measuring the voltage of the battery. It's not a big deal, right? And that's available for anybody to measure, right? So all you need is a little system that keeps measuring that voltage, has some intelligence, maybe from other batteries that have failed in other cars. So that's where the communication part of Industry 4.0 comes in. And if it can use that intelligence to give you predictive diagnostics or what's called prognostics, right? And tell you that it's going to fail, so be warned and don't be surprised the day when it fails. right? So at least you can do something about it, right? So I think this is a very simple example, but I'm sure that once you hear this example, you can extend it into so many cases.
Yes. Are you
Right?
seeing it being extended into many cases?
Yes, we are, very much, right? We even got an inquiry where they want to predict when a light bulb is going to fail.
Oh, okay. Good data to have.
Right, because that's a critical piece of equipment, right? Even though it's a cheap thing, you want to know if it's going to fail, right? So that you can keep a certain number of light bulbs in stock. And if you take a department store today, and you'll be, if you have ever counted the number of tube lights, you'll be pretty shocked at how many tube lights actually run in a typical shop. It's hundreds. And if there are failures there, it's actually a big deal for them, right?
Yeah.
So
yeah, that's true. So,
yeah, so this is the power of data, right? And sensors.
And that's true. And, even like in using sensors, so you have, adding sensors, then there's a lot of work we've seen, happening in IIoT. So you have IoT, which is your sensors and automate, putting it in. But then there's another thing where the sensors themselves are intelligent in a way and then know how to behave and do. So are you seeing a lot of work happening, or like, is it being applied into industry, or is it still at a research phase?
Yeah, so one trend, I think there are many trends, but one trend that we are kind of seeing is where, yes, since you mentioned IoT, to get into a very industry kind of context, I work with a center at IIT Research Park. It's called the Advanced Manufacturing Technology Development Center. I'm on the committee of that. It's called AMTDC. There's a website which people can look up. So one of the projects we're kind of running there is if you take a given machine, like for example, a grinding machine, which is commonly used in a lot of factories, right? Today it is the operator's skill to set the parameters of that grinding machine in order to get a certain finish at the on the sample that you're grinding, right? So the question becomes, how do you make that machine itself intelligent, just like you asked, right? So in other words, you need a bunch of sensors measuring what, so with the complete domain understanding of how grinding, the physics of grinding works, you will have to figure out what parameters are important to get the output of a grinding process, right? And maybe it's temperature, maybe it's pressure, maybe it's a combination. There's multiple parameters, right? So what you want finally is the quality. You want the finish, right? So if you can make the machine intelligent enough, so just tell the machine, I want this quality at the end of the process. You figure out the parameters, right? And I think that is a very interesting aspect of IIoT.
Yeah.
And this particular center that I am working with actually has developed an app for doing this exact thing for grinding machines. And they're extending it to other machines as well. Okay. Right? So, and that app is actually available for people to download. And why have they made it available? Because people can experience for themselves the magic of adding such intelligence to what they originally thought was a dumb machine.
Yeah, it's a grinder. You just think,
yeah,
exactly. What are we going to do with a grinder? But if I can get the finish, so this is actually transferred into. So it's actually like people can actually use it. So they made the transfer.
So yeah, the catch is you need the app and you need the sensors, right? So you need hardware too, right? So with only the app, I think you'll have to get a little creative on how you interface that to sensors yourself. But the center is actually helping people do both, impregnate or put in the sensors in the machine at the right location so that it's measuring the right things. If I remember right, they've even done it for a lathe, for a lathe. Yeah. So for a lathe, it's a turning machine, right? So you have a cutting tool, and then you have the sample that's that you're machining that's turning at high speed. At a very first level, they've done a very simple thing, but very profound thing, where they're measuring the temperature of the sample, and then they're feeding that information back to the lathe, where there is some intelligence that happens in between, because an unknown increase in temperature actually affects your final dimension. And if you know how the temperature is increasing while you're cutting your sample on the lathe, then you can adjust your tool pressure, etc., to get exactly what you want in the end, right? So those kinds of, that kind of intelligence, I mean, even though at this stage it may be a little basic, I think for the lathe example, it was a little basic. For the grinding, they're actually giving a much more comprehensive tool. So these are classic examples of IIoT, which is today literally adding value. And centers of this sort are giving away these apps so that you can actually experience these things for yourself. And you can take a call that and figure out whether you really need something.
Yeah, that's really good. That's good. And it's nice to know it's happening at our science park in Madras.
Yes.
Yeah. So, another major component of Industry 4.0 is where we're seeing a lot happening now during this pandemic usage of is 3D printing. So, and right now, I think, it's used conventionally mainly for prototyping as well. But do you see like a big shift happening rather from, the shift making just for prototyping to actual fuller scale manufacturing?
Yeah, I think it's happening in certain industries. So you're right. I think when 3D printing came into the world, it was meant for rapid prototyping. So you have ideas of complex geometries that would take a long time to do in the conventional way. So 3D printing was a very nice way to get it done quickly. And you get a touch and feel of what you want to make, right? We use that a lot in R&D as well, because very often describing a concept to a customer is only partially effective. But if you can make a concept and hand it over to a customer in like the first month of the project, for example, and that customer can get a live touch and feel of how this thing is, right?
Yeah.
And it works wonders. And of course, as soon as they see it, they will suggest a lot of improvements, which, which
but
is,
that's
I think,
good though if they do, because it's at least it keeps it flowing in the right direction, the project.
Exactly, yeah. But then to your point, I think a lot of industries, especially at least in our experience, the aerospace industry and the medical industry, where the volumes are not too big and the complexity is high. Right, I think those industries are a lot ahead in adopting this. For example, we have heard of 3D printing of titanium being tried seriously by aerospace industry, and with medical industry, I believe plastics themselves are quite a popular item even today, because plastics are a lot of different plastics are medically inert. We ourselves, without giving too much detail, are just starting a project for a doctor, where we are attempting to 3D print artificial bone. Actually, it's not strictly artificial bone. It's actually a precursor to bone, which kind of makes the body make the bone itself by itself.
Okay, wow, it's quite an interesting thing. So I guess with 3D printing, complexity is free. With 3D printing, you can build different components. You don't have to worry on the design of it. So it's more, it goes to more, your design is, you rethink the design quite a lot. It's more towards pure functionality, your design, rather than buildability.
Correct. Yeah, so the complexity comes for free. I mean, you can pretty much make any complex geometry. But making complex material is still a big problem today in 3D printing. You have various kinds of plastics that you can print. 3D printers come loaded with various different plastics that you can print individually or in combination. But then printing of metal is still a very elusive process. One thing is because it's pretty expensive even today. Secondly, the biggest issue is delamination, where 3D printing by definition is something that you do layer by layer. Right? It's like plywood in that sense. Plywood is wood stacked layer by layer. So when plywood chips off, when it fails, you see layers peeling off. Right? That's how plywood fails. And 3D printed structures also fail like that. So the bonding layer to layer, right, is still a topic of research today. right? So if that is a kind of failure, that is a problem in the end product that we are making, then 3D printing may or may not be the right answer for that, right? So again, can you do some post-processing to make the layer bonding even better? All those are questions that are out there, so there's still plenty of R&D to happen. The other, of course, problem is, like, as I said, we are printing bone precursors, right? These are extremely exotic materials. These are neither metals nor conventional plastics. So the entire process has to be redone to build a 3D printer which can print these kinds of materials. And these materials have to be biocompatible and also what they call bioactive, because they do something in the body. They go and react in a favorable way to certain components in the body. So all of that is kind of creating a huge R&D space for 3D printers. And the other half of 3D printer research is, once you've printed it, right, and once you have a product which is 3D printed, what are the inspection technologies to find out what's going on with this product?
Okay, yeah.
Because by definition, you probably 3D printed it in the first place because it was a complex geometry. So there's a lot of internal detail. So how do you non-destructively inspect the insides of a 3D printed part, a complex 3D printed part, right? Yeah. And if you think about it, there's no real answers out there. Techniques like ultrasound and infrared and all that only penetrate a small of the first few millimeters of the surface. So in fact, something else that we are doing along with a sister company of ours, which is located in Japan, is we are actually actively selling now X-ray equipment, and these are very high energy X-rays, which are coupled with CT scanners. Just like the medical CT scan, these are literally the same CT scanners, but they use higher energy X-rays versus medical. And they go around this 3D printed object, and they can literally make cross-sectional images, just like the medical CT. And the software will assemble these cross-sectional images to give you a complete 3D image of a very complex geometry. So that's literally the only way to look inside a 3D printed part, especially if it's made of metal.
Okay, that's quite complex then. So it's not the easiest thing to do. So hopefully, maybe what timeline do you think it would take, like, for 3D printing to be a more realistic way of actual going manufacturing? How long do you think? How far away are we from that reality?
I think there will be hybrid solutions for a few years to come. For example, if you think of injection molding, it's still the absolute cheapest way to make plastics.
Yeah.
Right? But the molds the dye is expensive.
Yeah.
So what if you could 3D print the dye? Because it's a very intricate component, right? So that the cost of the dye becomes lower, but you still make the mass production using the dye, right? So I think hybrid solutions of this sort will present themselves, and we'll have to get creative about this for the next decade or so, right? While in parallel, 3D printing itself evolves. Yeah. And becomes more and more of a mass production technique.
Yeah, that's right. More affordable as well.
Exactly. Yeah.
So, keeping in line with everything that you've discussed, what will it take for the world to recognize India as a destination for, high-tech manufacturing or even contract like R&D services, innovation?
Yeah, great question. When we started Contract R&D, we did it for two reasons. One was the very simple fact that there is a market opportunity. There is a gap in the market between the R&D that happens in academic institutions and the R&D that's required by industry.
Yeah.
Right. So if an industry or if someone in an industry wanted to invent a new technology, they only had two options: either to assemble a complete team and spend the money internally to do it, or to get it done from a professor at a university, right? There was no by industry for industry option, right? So we thought, let's grab that market space, because industry is very comfortable working with other industry. Yes, it's a little more expensive than working with academia, but then it's probably worth it because you actually get done things towards a real product and towards strict timelines. So that was one reason. The second reason was the more noble intention of showcasing India itself ultimately as a destination for R&D. So thankfully, the IT industry has proved to the world that India can be a great outsourcing destination.
Yeah.
In that case, for IT, right? So people now know that where India is on the map. They know a little bit about Indian culture. They've traveled to India. So they kind of have a basic confidence that Indians, in terms of outsourcing, can deliver. Now I think it's time to climb up the value chain in outsourcing. Right, so we started with data entry, we went to IT services, we went to engineering services, not necessarily in that order, but I'm just saying the gamut of outsourcing that India does. But something as high-end as innovation and research, I think other countries have kept close to their heart. They haven't outsourced much of it. Whatever has been outsourced so far is within their own companies' captive R&D labs in India. Right? It's not been a more open kind of outsourcing. So we have to break that, right? We have to prove to the world that, and I think we have the brains.
Yeah.
I think it's the point is to bring all the talkers and make them focus and make them do something.
Yeah. Now is a good time to get everybody to focus as well.
Exactly.
Yeah, that's
exactly.
true.
Yeah, so I think it can be done. I think we have, of course, what we are doing is a drop in the ocean. And ultimately, to climb up this outsourcing value chain, a lot more companies like us have to come into the picture. And someone like the government has to wake up to this opportunity. We have also tried to highlight this opportunity to the state and to the center. I don't think we have done it well so far because very few people know that somebody like this exists. But I think it will happen in time. For example, the Tamil Nadu government invited us to organize the R&D portion of the Global Investor Meet that happened some time ago at the Chennai Trade Center, which was a very good start because it was a sign of recognition. The government had invited us to do that. So we showcased in that meet, that was in the context of the state. So for the purpose of that meeting, we showcased the R&D ecosystem in the state. So we showcased the fact that various components of the R&D ecosystem exist in the state, namely the academic institutions, the research park, industrial R&D organizations such as ourselves, and also the market for R&D. So the eagerness of industry in Tamil Nadu to source R&D from various places. The entire ecosystem is what we had showcased in that global investor meeting. Right, so that's the start. But at the national level, I think we need to make a lot of headway. And back to Make in India, as we originally said, I think we need to do R&D in India first before we can do Make in India.
Yeah, and I mean, that's what will drive Make in India, really.
Exactly. Yeah, I think ultimately that has to drive. In the interim, yes, you can acquire some technology. But ultimately, you have to do R&D to get there. Yeah, and manufacturing also. I think India has been making great strides in manufacturing, but then we still have a long way to go. I mean, especially in precision manufacturing, we have a long way to go. So I think it's also a mindset as we do more and more R&D, the need for manufacturing more exotic things will also come up. But then something like 3D printing that you mentioned will be a disruptor. Right, it will, just like cell phones removed the need for landlines. It was just a disruptor, right? So we didn't need to worry about bad landlines anymore. So 3D printing will maybe come and disrupt the entire manufacturing scenario, where you don't need certain precision, expensive machines at all in the first place, right? So a lot of possibilities exist.
Yeah, and then also I think it will be really good for countries who want to show their manufacturing, and 3D printing becomes affordable. Then again, that would mean they'd want to do it in their own countries rather than outsource it to different countries.
Exactly, I agree. Yeah, and I think if people exit from China after the COVID situation for whatever reason, and if India stands to gain from that, right? I think we should capitalize on all fronts, R&D, manufacturing, I think the entire value chain.
Yeah, definitely, yeah. So thank you, Dr. Subramanian. At this point, we could take some questions. I know lots of people are eager to ask you questions. So we've got another one from Mr. Madhusudan, who would like to know, DMLS is being widely used for metal AM. A traditional metallurgist would call it a combination of powder metallurgy and welding. Inspection challenges have not been solved yet. Oh, I think it might be a point rather than a question. Can you see the Q&A on your screen? Or?
I can see a certain chat window. I'm not sure where I should be looking.
Okay.
If you can read it out, I would appreciate it. Yeah.
Okay, yeah, I'll read it out. So I think we've got another question from Mr. Siddharth Sivaraman, who'd like to know, there's a lot of money that is allocated to R&D, but unfortunately it goes into government labs. The effort should be to divert at least a portion of it to private labs. This was done when certain orders were reserved for the private sector in the defense and aerospace industry. I'd like to know your opinion on this.
Yeah, so I completely agree with that statement. And I think I just have to repeat a couple of things that I said earlier. That I somewhere feel that up there in the echelons of the government leadership, there is an intent to fund private R&D as well. But how do you make it flow down to the grassroots level, right? So for example, we have seen calls for proposals, which we have even responded to, that on paper say that private R&D labs can participate. But then when you actually fill in those forms, certain fields are still the old fields. I mean, they will limit the individual salaries that you can claim to a research assistant salary of 25,000 rupees a month. And clearly, if I pay 25,000 rupees a month, I'm not going to get scientists working for me, right? So things like that at the grassroots level, I think still need to be changed, even though the intent seems to be coming up. And the second thing is, I think the DSIR approval process actually makes private R&D labs eligible for certain kinds of R&D funding. But unfortunately, we haven't seen any of that translate. But an exception, again, that we are seeing is this, as I mentioned before, the TDF, the Technology Development Fund of the DRDO. That is very industry friendly. And I think we will very soon start working with DRDO on those schemes. We have already started engaging with them. And so that is a very patriotic thing for us, because a lot of those projects are things like sensors, which Indian defense is currently importing from foreign countries. And to be perfectly frank, I think the foreign countries are fleecing us on the prices and the spare parts and all that. So making it, developing and making those things in India will, I think, even in many cases, reduce the price like 10x, 20x kind of numbers. Yeah, so there are great opportunities out there. I think the government just needs to engage a little more with private industry on the topic of R&D.
Okay. Yeah, we got one more question. We see in many instances research done in India patented or registered outside of India. Do you think it's a dilution in the value chain or loss to the country? How do you think we can stop this?
Chandri, I'm sorry, your voice is a little low.
Oh, I'm sorry. Yeah. We see in many instances research done in India are patented or registered outside of India. Do you think it's a dilution in the value chain or loss to the country? How do you think we can stop this?
Yeah, I totally agree. I think it's a dilution. At least in my experience, and I think the reader can comment further if he likes, is this most often happens in the captive R&D labs that exist in India for the multinational companies. So large companies, global companies have R&D facilities in India. And for example, if it's a US company, they want to file a patent that came out of their Indian R&D office. There is, if I believe right, there's a process by which they can approach the Indian Patent Office for a waiver. And then the Indian Patent Office in most cases gives permission to file that patent not in India, but in the home country. So it seems to be an established process of giving away the patent out of India. Why this is done, I don't know. Maybe this is originally to make it more friendly to the global organizations who are setting up R&D offices in India. Maybe the government will change the rules in time. But then remember that the way patenting works, it's only applicable in the country that you patent. So if the idea that came out of India is patented only in the US, for example,
Yeah.
it can actually be freely copied in India, which
Yeah.
could be a plus point as well. Yeah.
That's true. That's true. So I think we've answered most of the questions. Thank you, Dr. Subramanian, for joining us for this webinar. I'm sure all our participants have found it very interesting. I have found it very interesting and very informative as well. And we will have a full recording of this webinar uploaded on our YouTube channel, Circen Technologies. Our previous webinar has also been uploaded on that channel. So thank you everybody for joining us for this session. We are in the process of confirming the speakers and the exact timings and the date for the next webinar session. So we will inform everybody about when the next webinar will be, and it will be announced on our LinkedIn page early next week. Thank you all, and I hope everybody enjoyed this. Thank you again, Dr. Subramanian. It was very nice of you to join us for this webinar and take time out.
And thank you, Chandni, for this very interesting initiative of having these webinars. So congratulations on the initiative as well.
Thank you. Thank you so much. Thanks to everyone. All of you, take care. Until then, please, all of you, be well, stay safe, and keep washing your hands. Take care. Bye-bye. Bye.